Hello guys, we are continuing with the design of our layout which we previously discussed. If you haven't watched the video, you might wanna take a look at the layout explained. We already did GR2, which we called it GR1, which is a goods receiving table. So today we are going to be doing GR3, which is Trough Sink for washing the goods that have been received. And without wasting a lot of time, let us go right into. This is the Trough Sink that we are going to design today. In the layout, it is GR2, which is Trough Sink for washing the goods that you've received from the suppliers. You don't want to take them into storage while they are dirty, so you wash them through here, put them into pallets and to trolleys and go to store them. As we discussed, that was clearly explained in our previous video of the layout, right? So here is the dimensions, and I will put this one in the description below so you can download it to follow the dimensions as you do your practices. You can even go ahead and use it in your fabrication, though it might be a bit challenging because I didn't put the cutting size of the trough body, but I'm sure if you are quite experienced in fabrication, you can get your cutting sizes from this, right? So the size of the trough sink is 1 meter by 600, 1 meter by 600, and as you can see, the upper bend, the bend from here, this side is 50 millimeter. Right behind here, can we zoom it slightly? It has an upstand of 75 millimeter, a bend going to the wall of 15 millimeter, and another one going down at 10 millimeter. The trough has a depth of 350 millimeter and 300 at the base, so that you may have it inclined. The reason why it is inclined, once again, is when you're washing, standing and washing here, you don't splash water onto yourself and it goes tight the drain. The drain hole is dia 50, 2-inch, that depends with your plumbing. Now it has legs of dia 32, as you can see. Dia 32, this is a rubber adjustable grommet. This is a dia 25 bracing. This is the one at the back, as you can see here, and the other one at the front, and 2 on the sides. And there is a ground clearance between the bracing of 200 millimeter for the purposes of ease of cleaning the floor, right? So if we go to Solidworks and we can close this up, open a new drawing, go to let me take this part, click OK, and we go to top plane, create a new sketch, and new sketch, we go to get center rectangle from the origin and dimension it. We give it the overall size of the trough, which is 1 meter by 600. Click OK and exit the sketch. As it exit the sketch, you can rename this sketch. Instead of calling it sketch 1, you can call it outer boundary, right? Now feature go to top plane, reference geometry, plane, offset it. You offset to whatever dimension, whatever distance you want. There is no harm in doing that, right? Any distance that you want is okay. And from the new plane, sketch, new sketch, center rectangle. Let's first do it at normal. Don't center it at the origin. Click anywhere but the origin. And as you saw, there is a bend of 50 millimeter. The difference between the overall size and the inner boundary is 50 at the front, 50 at the side, 50 at the sides, and 50 at the front, and 15, this 15 from behind there, right? So dimension from this to this 50 millimeter, this to this is equals to this to this equal to this. It's pretty okay. This and this is 15. That's it. Yeah. Exit the sketch. You can hide this plane. You can rename the sketch to inner boundary. Right. Now, once that is done, what we should be doing right now is coming up with this, the profile of the body. The profile of the body. How are we going to do that? Only one way to find out. 3D sketch. You go for 3D sketch. Then a line from the center of the inner boundary sketch. Take it down. Hit tab. Then again to the front of the inner boundary. See, there it is. So what we can do right now is to dimension the sketch. This is 350 and this is 300. This shouldn't be fixed, right? I hope I'm making sense. You can do a trough of 300 by 250, 350 by 200, depending with what you prefer, right? There is no harm in having this shallow or slightly deep, and also it depends with the kind of goods that you're going to be receiving there at the receiving area, right? So there is no harm at all. Now you exit the sketch and you go to plane, which plane? Right plane, yes, right plane, feature, reference plane, you take it to this point, right? That point. And while you are at that plane, you create a new sketch, and convert entities, convert the 3D sketch. Okay, now your sketch goes to the edge of the inner boundary. At that point, you go to sheet metal and create base flange. Direction on the opposite direction, and the distance up to vertex. You take it up to that point. Click OK. No. There's something that we didn't do here. Let me go to this. I edit you have to give sheet metal parameters. You give it thickness of the metal that you're going to be using. It's supposed to be 1.5 millimeter. 1.5 millimeter will give you a very nice job when you're doing your welding. Oh, this will be welding. Oh, that will be welding. So 1.5 is ideal for this trough. Okay, some people use 1.2, others use 1 millimeter, but when you are doing your welding all the way from here up to here, and you're using 1 millimeter thick sheet, it will wobble, it will deform under that, definitely. And since you will be welding on the outside, all right, I'm getting ahead of myself. We are going to talk about that later once we do the sides. So hide this plane. We can go ahead and hide the inner sketch. Really? Yes, we can go ahead and hide the inner sketch, and also we hide the 3D sketch. The 3D sketch, we hide it, make it invisible. So now what you need to do before you do many things is create this upstand. Then you go ahead and do the bending. You do the edges, the sides, and the bending. So here I create a tab on this face, then I go to, should I go for center rectangle? Should I center it? Yep, there you go. Select OK. This and this edge, you make them collinear. This and this outer boundary, we make them what? Make them coincident. Same applies to the other side. Make them coincident. All right. Now, when you look at your sketch, it is seated pretty. Now we give dimension of the height of the upstand is 75. Again, this you can do 100 if you want. You can do 50, whatever makes you happy. It's not, I chose 75, no particular reason actually. When you click, you exit the sketch, merge, you make sure you merge it, and of course you don't want to take it on the reverse direction. Take it on the reverse direction. In fact, the tab will refuse. See how it is going? So you don't want it going on the outside, on the reverse direction, right? So you click OK. There you go. You have your upstand. Yeah. So if you want, you can go ahead and create edge flange from the rear, that 15 millimeter bend. You click OK. You click edit the sketch, that line and this line, and make them collinear. Yeah, so that one will be accurately 15 millimeter. You don't have to keep typing there, and because of the bending allowance, if you do it 15 millimeter and you're going to get the flat pattern, it will definitely be bigger than 15, and you will lose your dimensions. So create another edge flange from the behind this. You can type, no worry, typing this 10 millimeter, because actually it will be hidden on the wall. So whether it becomes 10, becomes slightly bigger or slightly less, there is no harm, right? Now you go to edge flange, create edge flange in this side and this other side, and blind up to vertex. Where is the vertex? The vertex is here. Click OK. Right, our trough is really taking shape. Then you go to close closed corner. You choose this corner, the gap, keep the gap as minimal as possible because we're going to talk about that in a few. This side matches with this corner, and this face with this other one. Click OK, and you're done, right? So when you click your flat button is coming, yeah, which is pretty much okay. Now create edge flange, another edge flange. The beauty with fabrication and doing these drawings, it's very easy. It's not a tedious thing. Make sure the face is parallel. You see this because it's inclined, and if you do it at a 90 degree, it will also be inclined. So you do it parallel to face. Parallel to which face? Parallel to that face. That the surface becomes flat, right? Blind, don't do blind. Okay, if you do a blind, it's okay. You can do your blind, then click on the bend, edit sketch, this line and the line on the overall dimension, the boundary, the outer boundary, make it collinear, and that becomes 50 mil. Exit the sketch. Now the other side also you do edge flange. That is 90 degree, because this is 90. There is no harm in doing it at 90. You don't need to do it parallel to, you don't need to change anything there. Click OK. Then as the drill, as we have done with the other, edit sketch, make this line, make this line collinear with this line. And the same thing will happen on the other bend, and you're good to go. If you want still, you can do it up to vertex, which will come. You choose the vertex to be that point. Okay, now the purpose of this sketch, the outer boundary sketch, is done. You can hide it. Go ahead and do closed corner, same parameters, no change there. So this corner, you are going to have some trouble with yeah, that should work. That's okay, right? And our closed corner is okay. You go ahead and right plane, mirror, where we feature, mirror. What do you want to mirror? You want to mirror this closed corner about that plane. If you want, you can go ahead and do another closed corner here, but so many tricks on how to do this thing. Go back to shade metal, edge flange. This an edge flange here, that side, and this side, and here we saw it is 35 mil, blind of 35 millimeter. Right click. Okay. Now, finally, we have our edge flange here, and here. And that bend should be 15 millimeter. You can even do 10 if you want, but 15 is always ideal. And our trough body is done. You can go ahead and save it in your folder what is the name of our folder? Sorry, tutorial GR2 part number. We do it GR2, sorry, 2, and say body, trough body, trough body, trough body. I told you there is a reason why I'm saving my items with the as per the layout, because I intend, once we are done with designing all the items, we try to make an assembly of the components. We do a layout of the 3D components and see, as we learn, see what it will look like, right? So the only thing that is remaining here, do a sketch at the bottom so that we may create the drainage hole. Yeah, normal. Our hole should be at the middle of that and that. We are passing through the origin, so actually it should be a construction line. Then we do a hole, we choose this and this line and make it coincidence, make it midpoint, right? Then we give it dia 50 millimeter. That will be okay. When we go to feature, extrude and cut, link to thickness, your hole is done. Now I should mention something really quickly later on at this point, right? Now the design of this trough, the tap, you can have two taps actually, two people can operate, but 1 meter is ideal for one person, so one tap is pretty much okay. If you are expecting to be receiving a lot of goods, you can have it a little bit longer, say 1500 millimeters, so that you may have two taps, so that two people will be washing the items, the goods, right? But this is 1 meter is ideal for one person. It's a small kitchen, as I was telling you. Now if you can look at the design, especially here at the back, I don't have a bend going this side, then the upstand, then the back bend, right? Because the tap, the reason why you should be having a flat surface here at the back similar to this one is if your tap is coming under the sink, right? But now our tap will be coming right from the wall, slightly above the backsplash, and feel me, the tap will be coming right from the wall. That is why this the upstand and the back side of the trough is one continuous thing, because we don't need to put provision for tap, and we don't even have to have the tap, the provision for the hole for the tap on the back side of the trough. It will be right on the wall from the tiles. Use the plumbers fix their tap and you got water, right? Now another thing is, you can have this tap, this trough, you can have it wall mounted, so you can have brackets, mounting brackets, two of them on the sides, or you can have it standing with legs. Ours is freestanding, so it has legs, so we are going to go ahead and create the legs and the bracings and all that, right? So this we have saved. If you feel like changing the material, the appearance and all that, it's metal, polished steel, where is it? Steel, and it is polished steel, brushed steel, satin finish, mirror, matte, brushed steel, this one, polished steel, brushed steel. There you go. Oh, we might later on change the appearance when we'll be doing the layout, right? The layout. Why am I calling it the layout? That is not English, man. The layout. I can give you a sneak preview of what we will be doing in 1 second. Where is it? Where did I save it? Projects, Solidworks tutorials, tutorial layout, items, placed. Well, there was something that I had done. Close. I will work on it. So our first item was GR1. Here we have freestanding digital weighing scale. Then we have the one that we designed the other day, the goods receiving table. Now the trough will be sitting here, and as I was saying, the tap will be coming right from the wall. I didn't give a tutorial of the weighing scale because, well, I just did a weighing scale, a representation of a weighing scale, because this is just a solid, and ideally this part should be moving, right? Also, the numbers, the screen, the display screen, so many things are not there. It's just for a representation. Also, here we have our an under-counter fridge. Well, maybe we might want to take a look at the design of the same, but we will see. So ideally, this is the layout. I did the layout. I'm not a structural engineer, so I did the best I could. Goods receiving, dry storage, cold room, pastry area. This is the pot wash area. Here we have the dishwash area. Here we have support kitchen, the prep area. The chef's office is here. The hot kitchen will be somewhere here. This is the entrance, the door to the sitting area. This is the serving, the serving. The serving area will be somewhere here. This is the serving arch, and this is the kitchen. Opening for the dirty utensils, taking them to the wash up area, right? But we will talk about that when the right time comes. And also, we did the layout itself, that is through AutoCAD. This is the same thing that we are talking about. You might want to check the video. We will try to fill all these items. We'll design one by one, then fill them in that Solidworks 3D. We will also do it in SketchUp. We will also do the layout in Blender. We have so much work and a lot of things to learn, right? So let us continue with our Trough Sink. So this is part 1. We go ahead and save. Then we go to File, New Part, Part 2. Click OK. Top plane. This is quite easy. It's just a new sketch. We do a circular hollow section, that is a leg. Then remember we said our legs will be dia 30, dia 32. Dia 32 is ideal for that. Offset it, and the thickness of the leg is 1.2. The reverse direction. Sorry, what did I just do? Delete this and offset again. 1.2 in the reverse direction, right? That's pretty much okay. Feature, extrude, and push. How do we want to extrude it? Mid plane, or that's still okay. Direction 1, blind at 860, 830, because ideally the total height of the trough should be 860. So if we are at the grommet, 860, adjustable up to 860, somewhere around there. So our leg is done. Go ahead and save it as 2 GH2 CHS legs. Why we are doing circular, safety purposes, safety and cleaning around is always easy, other than a square hollow section. A square hollow section, that very, and it is also economical, right? Now before we do this other part, let me cancel it. Before we do the brace part, we will do the assembly so that we may use our tool to get the dimension between one leg to the other and to get the right bracing. All right, so we go ahead and do our new part, assembly, click OK, and our base part is trough body. Insert component again. That is our leg met. The top part should be lying on that part. Coincident relationship. Click OK. Then this tangent to this bend, the 15mm bend, where are we taking it? That bend. Where is it? Direction 2. Yeah, direction 2. Click OK. Again, tangent relationship. That one to this direction. Direction is okay, right? Click OK. Our leg is done. Now, if you might take a look quickly here, our welding will be right here on this the 15mm bend. That is where we'll do our welding. Remember, I normally keep saying that you can't do your welding here. You can't do your welding here. It will penetrate on the top. And again, if I may mention this real quick, the trough, remember this part when you're doing the cutting size and the bending. This part and this part will come in a separate part. So we will have a weld here, a weld here, weld running all through up to this side. Now, make sure that the gap is very minimal here. Very minimal gap, because you will be welding from the outside. Here you will be welding from the outside, and you don't want the weld to penetrate inside, because there is no way how you can polish here. There is no way how you can polish from the inside here. So what you're gonna do after welding is just cleaning with a pickling paste there. So we are creating products which are neat and smart for our clients. We don't want to do something which looks right? Whatever that one is. The only place that you will be having visible polishing marks is right here on the top and the front, and that's it. So your leg, make sure you weld it on the 15mm bend, right? So we open the top, the trough body, and you go to the front plane, mirror component to be raised. There's the leg, and yeah, it is pretty much okay. Till that, you go to the right plane, mirror components to mirror these two legs. There you go. So now we want to design the long bracing and the short bracing. Evaluate tape measure. Boy oh boy, the distance between the cylinders is 538. Remember, 538. So you can go ahead and create new file, new part. Okay, front plane, new sketch, circle, center circle from the origin, dia 25. Remember, our bracing is of dia 25. Select, then offset 1.2. The thickness is 1.2 on the reverse direction. Click OK. Feature, extrude. How do we want to extrude? Mid plane. Yeah, mid plane. 538. 38. Beautiful. And go ahead and save as part number 3. GR2. CHS. Short bracing. Right, now we go back to our assembly. We didn't save this assembly. Can go ahead and save it as GR2 Trough Sink. Sorry, Trough Sink. Okay. Now, measure again. We measure from the distance between the cylinders. Distance between the cylinders is 938. 938. So the long bracing. Go to file, a new part. Okay. Right plane, new sketch, circle, center circle, dia 25. Click OK. Offset 1.2. Reverse. Click OK. Feature, extrude boss, mid plane, 938. Now, the 938 and 538, if you have seen quite correctly, because you have to notch, you can't put this side directly and weld it on another cylinder. You have to notch it so that it may take the profile of the leg, the dia 38 leg. That is why, if you take a look, let's talk about that once we assemble, we put them into the assembly. So let's save this as part number 4. Is it? Yeah, part number 4. We can take this and edit instead of writing everything. Just long pressing. There we go. Now we go back to our assembly and bring in assembly insert. We take short bracing and long bracing. 1, 2. Now we can met our, you can go ahead and met which one? Where's the leg? Yeah, this is the leg. The right right plane of the leg and the right plane of the short bracing, right? The right plane of the short bracing. There we go. That's pretty much okay. Then we go ahead and take which one? Not top, front plane of the bracing and front plane of the long, no, front plane of what? Of let's see, yeah, front plane of the trough body. Exactly. That is okay. Then we go ahead and take distance of this and this part. The base should be 200 millimeter. Yeah, remember the clearance. Now we go ahead and take what are we looking for? Oh, the long bracing. It is, yeah, we can take the right plane and the right plane of the body of the trough. Okay, that is okay. Then we take the leg. See, it is leg. I want mirrored components. Yes, mirrored component. Yeah. What's going on? Okay, well, we take the front plane of the mirrored component and front plane of the long bracing. That's okay. Click OK. Then we take the top. No, the top of the what? The top plane of the long bracing and the top plane of the short bracing. That's pretty much okay. Yeah, that assembly is good. And now you go ahead and take the right plane and mirror component to mirror is this bracing. Cool. So that's about that. You know, we are in, exactly, this is what I was talking about. If you can see my assembly, the short bracing is going almost up to the center of the leg, right? So that you're not going to do a hole on the leg, right? That will be weakening. But the short bracing and the long bracing, you will notch it to take this profile so that you may do your welding right here. So ideally, can we make this change transparency? Exactly. Now the part that has gone inside the leg, right, should be outside. So when you notch your bracing, it will be on the outside. So your welding will be running. Let me go to the to this one. Your welding will be running right through here on the outside, right? I hope you get what I'm saying. Get my point, alright? Transparency. Yeah. So we insert component again, and this time mount is long bracing. Okay, met. we can't mirror this because it will come at this level and we want it at a different level. It start giving me all sorts of issues with, you know, editing relationships. I don't want to do that. Okay, so why don't I just bring in another bracing and go for the, is it the top, the front of the leg, and the new bracing that we've just brought in. Where is it? Where is that bracing? Mirrored component, we don't need you. Let us collapse all these things. Is it this one? Yeah. Thank you. Then we take the that right plane and right plane of the trough. That is okay. And we go to distance 200 between this and this, the bottom part of the bend of the front. That's okay. Yeah, that bracing is pretty much okay. So our trough assembly is ready. Now, why we put this here? Obviously, when somebody is doing their cleaning, their washing, you don't, they are standing and their legs are going almost under the trough. Don't want this disturbing. When you put it at this level, it will disturb. It will, you know, be annoying to the person doing the washing. Again, also for storage's purposes, you can be putting your crates right under here. You never know, you might need this space. In fact, other people, instead of doing the bracing, they put a slatted shelf under here where they can be storing a few items here and there. And it might be a very good idea also to have it slatted. Once you wash your items, your goods, put them under here. They drip all the water, because when you are taking them for storage, you don't want them going to storage with water, right? So grommet, I don't feel like designing grommet. You know the drill. That is an imported thing. You just buy it from the suppliers. Come insert it into the legs. But I had drawn the grommet in my practice drawing before doing the what do we call it? Solidworks Trough grommet assembly, open. Here is my rubber grommet. Yeah, take a look at it. So I made it concentric relationship, this and this concentric. Okay, I gotta pull it down. What's going on here? Concentric relationship between this and this. That's okay. Then can I pull a coincident relationship between this surface and this? That's okay. The mat is good. So if I could go to collapse this also, collapse this also, collapse this. collapse this. Yeah, I go to right plane, mirror component to mirror, that one, click OK. Then we go to the front plane, mirror component to mirror is this and this, click OK. There we are, our Trough Sink is done. Alright, it is done. I have a question for you people. Have you ever dreamt taking a shower? Give me the answer in the comments below, as you also do any question that you want me to answer as far as Solidworks sheet metal design is concerned. Alright? But if you've ever dreamt taking a shower, please give me the comment. Even if you've never, give me a comment, like and subscribe to more videos coming shortly. Have a pleasant day and thanks for watching, gang.